the only substance in our body that is all three. It is a mixture, a solution, and a colloid. Blood's amazing. The concentration of our solutions, that's just simply a measure of what is present. How much water is present? How much salt is present? How much sugar is present? If you go get blood work done, blood work is going to come back to the doctor in terms of how much sodium is present, how much phosphate. It's going to give an amount of these particles, these pieces. The concentrations in our human body are low. Your textbook is going to talk to you about something called osmoles, milliosmoles. The reason that you're going to see that term, you're going to see that on lab reports. When blood work is done, some of that blood work that comes back to you comes back as milliosmoles. Others come back to you as milligrams per liter, for example. So it lets them know when they're looking at those lab reports the amount of that substance that's present. For example, sodium. And there's a norm. There is a value on which these belong, or on which these should be found in the body. We should have a certain amount of sodium. We should have a certain amount of calcium, so on and so forth. We should have a certain amount of hormones in the body. All this type of information, they have a lot of blood work they can do now to check for that. They can check that A1C to determine the use of sugar by the blood. I think the A1C checks for the sugar in the cells in the blood now. I mean, it's just amazing to me what they can test now with blood. But, and this is huge, concentration of these particles will affect movement at the cellular level. Not only will it affect movement of those particles at the cellular level, it will affect the movement of water. You begin to affect the water amount in a cell, things can go wrong quickly. Something else with water and these particles and concentrations that is extremely important, pH. Does anybody know what pH actually stands for?
Potential hydrogen.
That power of the hydrogen ion. Do you know anything about the pH scale? If we're on that pH scale, we tend to see it as like 0 to 14, 7 being neutral, anything below 7 being acidic, anything above it being basic. Blood should be 7.45 on the pH scale. But, and once again, huge, concentration has an effect. Have you ever heard of something being measured logarithmically? What does that mean?
By powers of 10.
By powers of 10. So, if I have my pH and in the blood, my pH is supposed to be 7.45. Well, because everything on the pH scale is logarithmic, I've got 0, I've got 14, 7 is considered neutral. Any movement on this scale that, if we're looking at the H pluses being acidic, any movement like from 7 to 6 to 5 to 4 to 3, it increases by a factor of 10. So let's say at 7, I have 100 H pluses that are present. If I go from 7 to 6, it's increased by that factor of 10. So 10 times 100, I'm now at 1,000 H pluses. Is everybody following me? Now, in my blood, if in my blood I'm at 7.45, and because these H pluses increase by a factor of 10, and at 7.45, I have buffer systems in my body, like bicarbonate, phosphates, some proteins, mechanisms found, I think the picture's covering up the D, but mechanisms that keep my blood at 7.45. Is there a problem if the pH of my blood goes to 7.35? You better bet it is. Because I have increased by a factor of 10 those H pluses. This means I have now offset the pH of my blood. I have affected my systems in the body that can offset that pH. And this is a stress to the body. I may have the materials for it to work and balance the pH. I may not. And if that's the case, it's going to become a cycle that will continue to drop. If I don't have the ability to affect that 7.35 and bring it back to 7.45, it's going to continue to drop. And guess what? You're going to get sick. Because your systems, such as your heart, your lungs, your kidneys, your liver, are going to be working to try to affect that high acidity, as well as your brain, your nervous system. Things are going to go wrong. So pH, that concentration of the H pluses, is very important. The body works very hard to keep pH at 7.45. And when it can no longer keep it at that point, other systems are going to get affected and things are going to start to break down. So pH is heavily monitored by the body. The brain works extremely hard to manage its pH. Our oxygen, we already mentioned how important that is. How important it is at that cellular level, because that's where it gets used. When we have that process of cellular respiration occur, the waste product is CO2. Carbon dioxide, it is a waste in our bodies. It affects pH, which is why the body works hard to get it back to the lungs and we breathe it out. Under normal conditions, we're doing this all the time. Other physiological conditions that could be present, i.e., respiratory problems, okay? Person with severe COPD, for example, their pH will constantly be affected, which is why people who have something such as COPD tend to have a lot of other health problems, like their hearts are affected, their kidneys are affected, and so forth, because of this inability to get rid of all that CO2. So CO2 is our waste. We do get rid of it. It's made during that process of cellular respiration, where we're utilizing our foodstuffs. All right, before we get into this one, let's take a break and be back at 9:30.